Hello everyone, my name is Shyam Manawat and I welcome all of you once again to the lecture number 3 of series Progressions. In this lecture we are going to learn geometric progression. Geometric progression. I hope you have gone through the previous lectures and understood what is arithmetic progression. Geometric progression is a progression which has common ratio between two consecutive terms of the series. For example, say this one. You have 5, 25, 125. So if you take the ratio of second term with first term and ratio of third term with the second term, see what you get. Second term is 25, first term is 5. Third term is 125 and the second term is 25. What do you get here? 5, 5. When you get the ratio of consecutive terms common in any progression or any series, then that is called geometric progression. That's how you identify geometric progression. Here, the nth term in the geometric progression, well, before that let's understand the terms. So here n always represent the number of terms, an is nth term, a is for the first term, we have discussed in AP also, arithmetic progression also, a is the first term, and r is the common ratio, this 5, 5, so r is the common ratio, okay. Common ratio r raised to what? N minus 1. That is the formula of nth term. Note down this formula. An equal to a into r raised to n minus 1. Yeah. Okay. 10th term. Let's find the 10th term. 10th term is what? A into r raised to 10 minus 1. That's how we write the 10th term. Now, if I want to find out for this particular question, I know the first term is 5 and the common ratio is what? 5 itself, right? So, for the 10th term, I will say 5 into 5 raised to 10 minus 1. Yeah, so that is 5 into 5 raised to 10 minus 1. So, now if you apply the indices property here, which says what? A to the power n into in general, okay, let me not use a because we have a here also, you might get confused. Let's say x to the power p multiply by x to the power q, that will get you x to the power p plus q. Power gets added if the base are same, okay. So here we can say this is 5 raised to 1 plus 10 minus 1, so basically 5 raised to 10. Now let us express the 10th term for the series in this way itself, because 5 raised to 10 will be really a big number. Yeah, if you calculate, what you get? 5 into 5 into 5. The calculation is not the objective. Objective is whether you are understanding how to apply the formula or not. 4, 5, 6, 7, 8, 9, 10. This is the 5 to the power 10. Yeah, but as I said, the objective is to understand how to apply and when to apply this nth term formula and what is GP. Yes, so let's say 5 raised to 10. That's, keep it easy. Yeah, let's see next question on the same. The fourth term and the eighth term of geometric progression is 3 and 1 upon 27 respectively. Find the 12th term. So what do we have here? The fourth term, which can be represented as a, which is first term, r, which is common ratio, to the power 4 minus 1. So a into r cube. Similarly, the eighth term can be represented as a r to the power 8 minus 1, that is 7, right? So this is given as 3, the fourth term, and seventh term is given as 1 upon 27. What do we need to find out? We need to find out the 12th term. So 12th term A12, that is what? A into R raised to what? 11, 12 minus 1. This is what we need to find out. Alright. Okay. Now, can we find out, we got two equations, two variables, A and R, two variables and two equations also. Now, up till here, we use the formula, and then rest is how do you deal with the equation. That's completely on you. So what do I do here? I divide the second equation by first equation. So I get what? AR7 by AR cube equal to 1 upon 27 by 3. Alright, so here A and A get cancelled, and indices property again. The indices property again, what is the indices property? X to the power P by X to the power Q. When base is same, what do you get here? X to the power P minus Q. The power gets subtracted. Yeah. When they are in division and base is same, power gets subtracted. So here R is to 7 by R is to 3 should get you R is to 7 minus 3, that is 4. Here if you simplify, this become 1 upon 27 into 3, that's 1 upon 81. Now tell me, if R to the power 4 is 1 upon 81, what should be the value of R? The fourth root of 1 upon 81, 81 is 3 raised to 4, so that will get you what? 1 upon 3, right? You got the common ratio. Applying the common ratio in either one of the equation, let's say equation number 3, equation number 1, I can find the value of A. So I have R raised to 3 equal to 3, and that is 3. Here we have A and the 1 upon R, sorry, not 1 upon R, it's 1 upon 3. What am I doing? R equal to 1 upon 3, substitute here. What do you get? Cross multiply. So 3 into, that become 3 upon 1 to the power 3. So A is what? A is nothing but 3 raised to 4. That's what? 81. Correct? Now, what do we need to find out? We needed to find out what is 12th term. So 12th term here will be 81 into R, which is 1 upon 3 to the power 11. Here 81 into this will, no, 81, let's write 81 as 3 raised to 4. Okay, and if you multiply, this will be 3 raised to 11. That is the 12th term. Now, so 12th term here, that is what? Simplify this. Yeah. You can go with subtraction, or you can also understand that 3 is multiplying itself 4 times, 3 is multiplying 11 times. So what you get is 1 upon 3 to the power 7 only. Okay. This will be 12th term. Yeah. This is the 12th term of the series. Are you understanding how to apply the formula of nth term in GP? Yes? Okay. Let's see one more question. So here we have, in a geometric progression, you can pause the video and try attempting it by yourself. That's quite similar to the previous one. In a geometric progression, second term is 9 and sixth term is 729. Find the fourth term. Okay. So second term is 9. That's what? AR. I hope you are comfortable with this. And ninth term is, sixth term is 729. That's what? AR to the power 5. Okay. Now, if you simplify this, second divided by first, what do you get here? 729, which is nothing but 27. Okay, yes, 27 power 6. Okay, ठीक. Divide by 9, and that is AR to the power 5 by AR. A is cancel, Here we got fifth power of r, and this is r raised to 1. Apply the indices property again. Which one? Which one? Remember, x raised to p by x raised to q, that will get you x raised to p minus q, right? So here, this way you will get r raised to 4. Now if you cancel this, divide this, 7 8s are, and this is 1s are. So this is 81. Now r raised to 4 equal to 81. So what should be the value of r? Of course, 3. That's the value of r, right? Now question said find the fourth term. For that I need a also. So I will use equation number 1, that is ar equal to 9, and if r equal to 3, so a will be equal to what? 3 again, first term. Question said find the fourth term. Alright, fourth term will be very easy. The fourth term will be ar cube, isn't it? So a we know, that is 3. R also we got 3 cube. So what do we get here? 3 into 27, that's going to be 81. So fourth term is what? 81. That's what we get. Fine. So I hope you understood how to apply nth term formula in GP and what is geometric progression. That was important. The next concept is nth term. Nth term, sum of nth term for GP. So sum of nth term for GP, geometric progression, that is given as a into r raised to n minus 1. See, this minus 1 is not in power, okay, by r minus 1. Yeah. Or if r is let's say it's less, this is for r more than 1. If it is r less than 1, we can say r 1 minus r raised to n by 1 minus r. It's one of the same thing. So understand the condition. Here this is when r is more than 1. Yeah. And here this one we will use it more than 1, or you can say positive also. That's also fine. So first one is for positive and second one when r is negative. Yeah, r is negative, so we have 1 minus r. If r is positive, then we have r minus 1. Simple to understand, right? We also have one more formula for sum of infinite series, infinite terms of GP. So that is a upon 1 minus r. An infinite term we apply when r is in decimal, that means between minus 1 to 1. Yeah, in that case. Okay. All right. So question. Here we have find the sum of first 4 terms of geometric progression whose first term is 6 and whose common ratio is 2. So question said find the sum of first 4 terms. What do you need to find out? Sum of first 4 terms. So what's the formula? First term into common ratio raised to number of terms minus 1 divided by common ratio minus 1. So first term is what? 6 given here. Common ratio is 2. Common ratio is 2. Power 4 minus 1 by 2 minus 1. Let's go further. 6 multiplied 2 raised to 4 is what? 16. 16 minus 1 is 15 by 2 minus 1 is 1. We never write 1 in denominator or in multiplication. Now 15 6 are 90. So this is your sum of nth term in GP. Are you getting it? Are you getting it how to apply the formula? Yes. Let's try a couple of more questions, or let me give you this. Okay, let me solve the question number 2 and give you question number 3 as homework. So you need to write the answer in the comment box because both of them are similar. Question number 2, how many terms of GP will get you sum as 120? So you have Sn given as 120. You need to find out n equal to question mark, where first term is equal to 3 and common ratio. See, it's 3 multiplied by 3 it will be 3 square. That means common ratio is also 3. So you will say sum of nth term, which is 120, equal to the A. You want me to write the formula first? No worries. Although I assume that you understood the formula well. A r to the power n minus 1 by r minus 1. So here 120 is equal to 3 multiplied by 3 to the power n. We don't know what is the value of n, so I'll write simply n, and that is 3 minus 1. Now let's simplify this. Have 3 raised to n over here and cross multiply this. So 3 minus 1 is 2, cross multiply. So 120 into 2 will get you what? 240. Yes. Now divide by 3. This 3 I'll take into the division. I hope you are comfortable with this. I don't want to write many steps to make it look lengthier. Simplify. Here I got 80. So if 80 equal to 3 raised to n minus 1, if 1 will go to the other side, it will become 80 plus 1 is 81, and that is 3 raised to n. That means here you will get n equal to what? Which power of 3 will get you 81? Fourth power, right? So n equal to 4. Okay. So n is equal to 4. So which term? How many terms? So answer is 4 terms. Same question, question number 3, same question, you can see this. How many terms? Try this out by yourself. Okay, find the common ratio. First term is given here, 3 directly. Sum of series is what? 3069 by 512. It is looking difficult, but it's not really. Yep, I mean, I know the 3069. You try doing calculation, I'm sure you will get the answer. Calculation, I know that my students are quite intelligent compared to me in doing the calculation. Do the calculation by yourself. Look at the next question. The next question is sum of first term of GP is 13 by 12 and their product is minus 1. Find the common ratio of terms. Alright. So sum of first 3 terms. Same as the previous, this lecture number 2's question which we have solved, remember? Sum of terms, and then we have done that. Where is it? This one. Here sum of AP, sum of 3 terms of AP. Similarly, here we got sum of 3 terms of GP. So let me assume the first term is A and common ratio is R. So the second term is AR and the third term is AR square. Now as per the question, A plus AR square is going to get you what? 13 by 12 as per the question. Whereas the product is A into AR square is going to get you minus 1. That means if I go further with this second condition, this is the first condition, this is the second condition. Here it gives me A cube and R cube. So that is going to get you what? AR cube equal to minus 1. Remove cube. Take the cube root of minus 1. Cube root of minus 1 is minus 1 itself. So the middle term AR is equal to minus 1, right? If AR is equal to minus 1, then I can say A equal to what? Minus 1 upon R. I will use this information to substitute in the first equation to eliminate A and only have R over there to get the answer. Now, if I do that, I have A equal to minus 1 by R. Yeah, so minus 1 upon R. So I will take equation number 1 here. Yeah, see, after forming the equation, I will leave up to you how do you want to solve the equation. Okay. Yes. Plus AR, we got minus 1 plus AR square. So we have A as minus 1 upon R into R square. Yeah, that is equal to 13 by 12. Okay, simplify this. Minus 1 upon R, minus 1 here. Simplify this, minus sign as it is, R and this will get cancelled. r equal to 13 by 12. Okay, simplify this further. Yeah, if you simplify this, you will get a quadratic equation here. So if you simplify this, you will get a kind of quadratic equation. Let's try doing this. So I take this minus 1 to the other side. So I have got minus 1 upon r minus r equal to 13 by 12 plus 1. So this is going to get you 25 by 12. Okay. Now simplify this. Simplify this further. What you get here? Let's take minus sign out. So 1 minus 1 plus r square by r, and if I take r, now cross multiply r to the other side, 12 this side, so you will get minus 12 and this is 25r. Simplify further, what you get here is minus 12r square equal to 25r. Simplify, take all the terms at the same side. What you have here, you get 12r square plus 25r plus 12 equals to 0. Simplify this further. So here I got product as 144 and I need two terms which sum should be 25. So 144, if you divide, you get 16 into 9 is 144 and 16 plus 9 will get you 25. If you have come across my concept builder videos of quadratic equation, I hope you can write the roots directly, write the value of r directly here, that r will get you either what? 16. So this is plus 16 plus 9, right? So minus 16 or minus 9 with this 12 as denominator. Yeah. So r will be either cancel by 4, so minus 4 by 3 or minus 3 by 4. Yep. You can use either one of them and get the answer. So question is find the common ratio. So common ratio answer is, it will be either minus 4 by 3 or minus 3 by 4. That is the answer. Okay. Fine. So I hope you understood how to use the sum of nth term formula of GP, right? Okay. So let's see what are we going to discuss in the next lecture. Fine. In the next lecture we are going to discuss sum of infinite term. So this is it in today's lecture. I will see you in the next lecture. Till then, stay happy, stay healthy and keep learning. Bye bye.